Alright guys, let's get started. Today what we're going to be talking about is we're going to take matter. Okay, and what I mean by matter is just things, stuff. Okay, we're going to take stuff and categorize it into one of several little categories. Okay, and the reason we do that is if you know what category it goes into, then you automatically can deduce or figure out kind of what behaviors it's going to have. Okay, and so there's two big categories. Okay, the two big categories are pure substances and mixtures. We're kind of forming a tree here. Right at the top of the tree, we'd have matter. Okay, so if I'm forming my tree, we have matter. And under matter, we have substances and mixtures. We'll get to mixtures later. Let's start with substances. Okay? If something is a pure substance or a substance, you don't have to say pure substance, you can just say substance. Let's read that definition. It is a type of matter with a fixed composition. Somebody tell me, fixed composition, what does that be meaning? It's made of one thing. Or it's made of the same thing repeating over and over and over again. It's a pattern. Okay, it's not like a painting where everything, you know, like a Van Gogh, and you look over here and it's different over here and different over here. Okay, it's the same all the way through. It's like a fractal, I guess. Okay, so in other words, if you got down and you got closer and closer and started picking it apart, everything would be exactly the same. You had some pieces over here and some pieces over here, and you pick something apart, all the pieces would be the same. Okay? A substance is going to be either an element or a compound. Okay, so matter is either a substance or a mixture, and if it's a substance, it's either an element or a compound. Okay, if something is an element. Remember earlier I gave you or a second ago I gave you the example of picking it apart and looking at the pieces? Okay, if something is an element, then there's only one kind of piece. That makes sense? There's only one type of piece. So in other words, you look at the atoms, and there's only one type of atom. Okay, all the atoms are exactly the same. They have the same number of electrons. They have the same number of protons. Okay, looking up here, guys, we have the periodic table of elements. Okay, so those are all the elements. If it's not up there, it's not an element. Unless it's an element that we haven't discovered yet, of course. And if it is up there, then it's an element. So if I said, hey guys, carbon, is that an element? You'd say, yes. Yeah, because it's up there. Okay? So some examples, guys. A penny is coated with copper. Copper right here is Cu, number 29. Okay? That is an element because it's on the periodic table of elements. Okay, so if I have a penny that's made out of copper, not all of them are made out of copper anymore, but the old ones made out of copper, if I pulled the atoms apart, I'd have nothing but copper atoms. Okay, nothing else. It's a pure substance. Okay, in your pencil, the graphite, okay, a lot of the time you call it lead, but it's not lead, it's an element. Does anybody know what element graphite is? It's actually called an allotrope, because there's different... This element appears in many different. It appears many different ways. It's called an allotrope. Anybody know what allotrope graphite is? It's carbon. Okay. Yeah. Another allotrope of carbon would be diamonds. Okay, so diamonds, pencil lead, same material, just appearing differently. Okay, same element. 90 of these elements are found on Earth. Okay, what I mean by found on Earth is they naturally occur. You can go dig and find them. So you can shovel and be, some uranium. Okay, naturally occurring. Okay. However, if you look up here, I see 114 up on this periodic table. I think that's expanded now, but we see 114 here. And so the rest of those are called synthetic elements. Okay, a synthetic element is one that's made by man. Okay, you can't go out into the earth and find. I'm trying to think of one that you can't find. I don't know. That some of them up there are synthetic. Yeah, that is. I can't think what the name of it is. It's something. I think the UUQ is ununquadium or something. I don't remember the name. Is that what it is? Ununquadium? Yeah. However, guys, they don't typically last for very long. What I mean by they don't last for very long, they're not stable. Okay, we make them, they fall apart. Okay. All of the synthetic ones are down here in the lower region. Okay. The lower it gets, the more protons they have. Why do you think synthetic elements would be unstable?
Because they have too many protons.
You're in the right track. What do protons do when you put two of them together? They repel. So if you put 100 of them together, what do? They really repel, right? Okay. So the more protons you have, the less stable it tends to be. Okay. So that's the reason why a lot of the synthetic elements tend to break apart. All right. So that's an element. Element. If I look at it, I see only one type of atom. Okay. A compound is going to be elements that are bonded together. Let's say I'm having a dinner, and maybe I'm eating some macaroni and cheese, and I say, this macaroni and cheese is missing something, it needs a little flavor in it. Could you imagine, guys, me picking something to put on my macaroni and cheese that was made of a silvery metal, okay, so like, it's a metal that's silvery, and a greenish-yellow poisonous gas? Okay? Really, that would be a bad choice of things to put on, we would say, to put on my macaroni and cheese. However, we very commonly put that on macaroni and cheese and other foods, and then that's just table salt. Okay? Table salt is a compound that's made out of two very, very different things. Okay? The silvery metal here is sodium. Okay, if you take sodium and put it in water, I'm going to show you what happens. There's a video right there. Mind hitting the lights for me? Huh? If you can find some sodium, then that's a good question. This is kind of sideways. I know that's kind of hard to look at, but we were just playing around in the chemistry lab, and got a little sodium, and this is water. And so this is just a little bit of sodium right here. Y'all see that little spot? And let's see what happens to sodium when we put it in water. What now? We're not having no labs on this, huh?
Oh, that's so sick.
Not any. We're going to blow stuff up. They might put my life in there.
No, we're not going to blow anything up that will put your life in danger. So that's sodium. Does salt have any of the properties of sodium? Do you put salt in your body and it explode?
No.
Do you put salt in water and it explode? No. Okay. Next part of salt is chlorine gas. Chlorine gas is what we use to kill bacteria. If you breathed in a whole bunch of chlorine gas, it'd kill you. It's poisonous. If you're in a pool and you want to keep your pool clean, what do you use? Chlorine. Okay, and it's used to kill the bacteria. Okay, it's poisonous. Okay. Would you want chlorine in your body? No. Okay. However, salt, does it have any of the characteristics of chlorine? No. Okay, so that's how we're defining a compound. A compound is made of elements, but it doesn't retain the properties of the elements.
So what keeps the sodium in something going?
Because it's not sodium anymore. Now it's sodium chloride, which is a compound. Once something becomes a compound, it doesn't have the same properties as what makes up the compound.
So then you put like chlorine tablets in the pool, it starts bubbling.
Well, chlorine is a gas, but it's. I think that's reacting and producing the chlorine gas. Yeah. So an element. You look at an element, you see nothing but that one thing. A compound. You look at a compound, and you see a repeating pattern. Okay, so I would see sodium chlorine, sodium chlorine, sodium chlorine, sodium chlorine. You see a repeating pattern here. Okay? So that's a pure substance. It's either an element or a compound. Okay? Notice, a compound is going to be the same way all the way through because it's just one thing. It's one thing that's different than what made it up. Okay? But it's only one thing. Okay? All right, now let's move over to mixtures. Okay, a mixture. Okay, a pure substance. It's the same thing all the way through, made up of one thing. Okay, a mixture is different. Okay, it's made up of multiple things. Okay, and the multiple things that make a mixture do retain their properties. Okay, that's important. Now listen up. In a compound, I have multiple things. They don't retain their properties. So if I mix sodium and chlorine, it's not explosive, it's not poisonous. Okay? However, in a mixture, if I just mix up some sodium and mix up some chlorine together, I could mix them to where you wouldn't be able to tell that they were there, but they would retain their original properties. If you ate some sodium and some chlorine mixed up, you'd explode and then get poisoned. Okay? So you see the difference between a compound and a mixture. A compound does not retain the properties, a mixture does. Yeah? Okay, we're going to have two different types of mixtures. The first type of mixture is called a heterogeneous mixture. Hetero means many or different. Okay? So if I have a heterogeneous mixture, I'm seeing many things. Okay? My rule is heterogeneous if it's obvious that it's a mixture. If you look at it, you say, that's obviously a mixture, then it's heterogeneous. So trail mix is a heterogeneous mixture. Pizza is a heterogeneous mixture. Beach at the sand. Sand at the beach. Sand at the beach would be a heterogeneous mixture. It has sand, it has seaweed, it has shells, dirt, okay, all kinds of things. Okay, that'd be a heterogeneous mixture. Okay, so in heterogeneous mixture, our particles are going to be big. Okay? In a homogeneous mixture, my particles are small. Okay, so for example, Coke, a cola. That was unintentional. Okay, if I look at some Coke, I don't see any. It looks the same to me. It's kind of blended evenly. I mean, really, just looking at Coke, would you be able to tell that it was a mixture instead of a compound? I mean, not really. To me, I mean, you can't look at a homogeneous mixture and tell that it's a homogeneous mixture. Okay. Most things are homogeneous mixtures. Okay. Most more common mixtures are homogeneous mixtures. Okay. Tap water is a homogeneous mixture. Okay. It's not just water. Okay. It also has chlorine in it. Yes, it has chlorine in it. It has fluoride in it. It has minerals in it. Okay.
So you shouldn't drink tap water?
No, tap water's fine to drink. I'm saying it's not pure water. Pure water, you need to get distilled water.
That water can be like sitting out. It was in a cup of this
You mean like
Distilled
bottled
water? Distilled water, they boil the water, they let the steam come up, and they collect the steam, and so the only thing that goes up is water. And they let that steam turn back into water. You boil it, and then
How you catch it?
you would have something cold above it, and so it would condensate on what was cold and then drip down. That's one way of doing it. I don't know how they do it industrially, but so think you have a pot here.
Is distilled water just like bottled water?
Not all bottled water is distilled. A lot is tap or spring. So you have the water's boiling, steam's coming off. I have a cold plate up here, and so the steam comes up here and it turns into little particles of water, and the particles of water drip down, and I collect them here, and I end up with pure water because everything else won't turn into steam. Okay. So homogeneous mixture. Homo means one or the same. Okay, so that means you only see one thing. I see the same thing. Looks exactly the same to me. Okay, can you now give me some other examples of homogeneous mixtures?
If you put ice in like a Coke, would it be a compound?
What do you mean?
Like right there, if you put ice in a Coke, would it be a compound?
Okay, what is ice made out of?
Water.
Water. Okay. So to me, that's a heterogeneous mixture because I have ice very obviously separated from Coke. So I mean, Coke has water in it. What about air? What is air? It's a homogeneous mixture. Okay, I don't see just a mixture. I mean, it has oxygen, nitrogen, carbon dioxide, hydrogen, a little bit, just very little bit, hydrogen. Okay. All right, so I'm gonna put two categories under here. Okay, so stick with me. We're almost done. Okay, we have a little time. Almost done. I know y'all are getting tired. Okay, another name for a homogeneous mixture is a solution.
So one you can see, one you can't see. Like you can see them, but you can't see the other.
You can see it, but you can't see that it's a mixture. It's evenly blended.
And then that one you can.
This one's obvious that it's blended. So, trail mix. I can see little different things there.
So,
There's not a fine. It's kind of a blurry line between these. I mean, maybe you don't have very good sight, so you think everything's homogeneous. Yeah, it's possible. Or trail mix from 5 miles away, looking through a telescope, may look homogeneous.
why can't you just call it a solution if it's the same thing?
What now?
Why can't we just call it a solution if it's the same thing?
Typically, a solution is a liquid. Typically. Okay. A homogeneous mixture could be air. It could be steel is a homogeneous mixture. It's lots of different metals combined. Okay. I wouldn't really call steel a solution. That seems weird to me. Oh no. Yeah. That still seems weird to me. Molten steel. And so here's everything we have so far. Okay, that's that basically this list here. Do y'all want that, or can I go?
We need the other slide.
That? Okay. I'm just going to run through the last two real quick. I'm going to skip the slide and just give them to you. Okay. The last thing is called a colloid. I don't remember how to spell it, so we're going to have to go to the slide. Colloid. A colloid is a solution this is homogeneous, but it's kind of murky. So to me, like a murky liquid, so like, I mean, even fog, okay? Anything that's murky, milk would be a colloid, okay? And so it has particles in it, but they're not heavy enough to settle down to the bottom. Okay, so fog, milk, steam, dirty water, but not real dirty water. It's kind of a little dirty. Yeah. Okay, a colloid looks like this. Let me see. Okay, notice when light shines through a colloid, you can see the beam of light. Okay, when light shines through anything else, you don't see it.
Can you go back?
Sure. Okay, so if you want to know if something's a colloid, shine some light in it, and if you can see the beam of light, it's a colloid. Is air a colloid?
No.
It can be. Okay, I mean right now I don't see beams of light. Okay, but I mean think when it's a real pretty day and you see like a sunbeam coming through a cloud, it's like ah, you know what I'm talking about? Like you see those. I mean you can see that beam of light, right? So that's kind of a colloid. Or if there's a really strong laser, you can see that laser beam. Okay, so air can be a colloid. The last one, guys, and I know I'm taking forever, is called a suspension. This last one. A suspension is heterogeneous. Okay, that means you can tell it's a mixture. It's got big old particles in it.
We put this on that show.
And it's going to go under heterogeneous. Okay, the best example of a suspension is, you know those snow globes? You look through a snow globe, you don't see anything, you take it and you shake it, and now it's snowing, right? Okay, so I have some particles, I take those particles, I mix it in, that's a mixture when they're sinking, and they sink to the bottom and they fall out. Okay, that's when they're up in the liquid, that's the suspension. They're suspended. Make sense? Any questions?
That's a lot.
I know it's a lot of information. But here's our classification of matter chart.